So this is problem number 10 of the practice problems from chemistry module 10. And the question is, what is the boiling point of a solution made by mixing 75.0 grams of zinc chloride with 375.0 grams of water? And the boiling point constant for water is 0.512 degrees Celsius per molality. Remember, molality is a concentration. So we know that this has to do with changing the boiling point of a solution. And so we know we are going to use this equation where delta T equals I times the boiling point elevation constant of the solvent and molality. And so we have to look at the problem to see what information is in there. So we know the mass of zinc chloride, and that is 75.0 grams of zinc chloride. That's how much we've measured out. And we know we are going to dissolve this 75.0 grams of zinc chloride in 375.0 grams of water. Now, when we look at our equation, right, we are looking for the new boiling point. And this is not going to give us the new boiling point, but it's going to give us the change in that boiling point of water. Remember, water boils at 100.0 degrees Celsius. And when we add a solute to water and make a solution, that means the boiling point is going to be raised, which is why this particular equation is not negative. All right, and so that change is dependent on the solute, and that is represented by this I here. And of course, again, this I represents the number of molecules or ions that molecular ion splits into when it dissolves. Kb is the constant, m is the molality. And remember that molality is equal to the moles of the solute divided by the solvent in kilograms. Okay, so the mass of the solvent. And so when we look at what we know here, we're only given two other pieces of information here, and that is that we know the mass of zinc chloride. Well, if we need to know the molality, we need to know how many moles of zinc chloride we have, right? And then we also need to convert the water from grams to kilograms. We are also, even though we're not directly told, we do know the I value because zinc chloride is our ionic compound, which is going to be dissolved in the water. When zinc chloride, you just have to remember how ionic compounds are formed. It's going to split into a zinc cation and two chloride ions. So the total for I is 3 because we have 3 different ions that are going to be found surrounded by water molecules. And of course, we're given the constant 0.512 degrees Celsius per molality. And again, molality is moles of zinc chloride divided by kilograms of water. So the first thing we need to know, since we don't know the molalities, we have to determine what the molality is before we can use this equation, because this is what we want to know. We know I, we know Kb, and we need to know molality, and so we're going to have to use this information right here to determine our molality. And so we know the mass, and we know how much zinc chloride we're going to use. We're going to use 75.0 grams. The question is, in that 75.0 grams of zinc chloride, how many moles are there in that sample? To find that out, we must first find the molar mass of zinc chloride. We know in zinc chloride we have 1 atom of zinc, 2 chlorine atoms. If we look on the periodic chart, the atomic mass of 1 zinc atom is 65.4 AMU. For 1 chlorine atom, it's 35.5 AMU. And I just multiplied by 1 for the zinc, and since I have 2 chlorine atoms, I need to multiply that atomic mass by 2. And that results in 65.4 plus 71.0, resulting in 136.4 AMU. That is our molar mass for 1 molecule of zinc chloride. Now, if I were to take my little bottle of zinc chloride off of the shelf and I were to weigh out on my balance 136.4 grams of zinc chloride, that 136.4 gram sample would contain exactly 1 mole of zinc fluoride. So this becomes our conversion factor. We know that 136.4 grams of zinc fluoride is equal to 1 mole of zinc fluoride. There should be an equal sign there. I'm not sure what happened there. So now we can go back and use at our sample, right? We have less than 136.4 grams of zinc chloride, so we know we have somewhere less than 1 mole of zinc chloride. So when you do the math, if you get a number that's larger, you know that you did the math wrong. So what do we do with the math? So we start with what we have. We have 75.0 grams of zinc fluoride, and we can put that over 1, because any number divided by 1 is, of course, that same number. And then we take this equation, and to help us remember whether or not we multiply or divide, we want to make sure that we cancel our grams of zinc fluoride. So in this case, we are going to divide 70.0 grams divided by 136.4 grams of zinc chloride and put 1 mole of zinc chloride in the numerator. The grams per zinc chloride will cancel, and when we 75.0 divided by 136.4 grams will equal 0.549853. I think the number went on. So then we have to look back at our numbers. There are 3 significant figures here. There are only 4 significant figures here. So we know our answer when we multiply or divide, we must have the same number of significant figures as the number with the least significant figures. So that's 3. So when I come over here and look, I know that I need to keep the tenths, hundredths, and thousandths position. And that number is a 9, but we have to at least look to the number to the right. That number is an 8, which means we have to round up, which means this 49 becomes a 50. But we have to keep that 0 here because that is a significant figure. So our answer is that we have 0.550 moles of zinc fluoride in this original 75.0 gram sample that I'm using in my problem. Now, remember that that is the moles of our solute, and we need to divide that by the mass of the solvent in kilograms. Well, we know from our problem that we are dissolving that in 375.0 grams of water, so we have to convert that to kilograms. And that's what we've done here. So we remember that for every 1 kilogram, there are 1,000 grams. So 375.0 divided by 1,000 grams tells us that we have 0.3750 kilograms of water. And yes, we have to keep that 0. There should be 4 significant figures in this answer. This first 0 is not significant. All right, so again, we go back to our molality. Molality equals the moles of solute divided by the mass of the solvent as measured in kilograms. And so in this case, we have 0.550 moles of zinc chloride divided by 0.3750 kilograms of water. And when we do that, we get 1.466666, which repeats until, so we just put a 7 there, molality of zinc chloride. But I have 3 significant figures here and 4 here, so my final answer must only have 3 significant figures. That means I'm going to go to the hundredths position, but I look to the right. This number is a 6, which means I have to round up. So my final answer is 1.47 molality. So I have a 1.47 molality solution of zinc chloride when I dissolve 75.0 grams of zinc chloride in 375 grams of water. Now we're ready, but remember, we weren't really looking for molality except for to use it in our original equation, because what we want to know is not just the change in temperature, but ultimately the question was asking for what is the new boiling point for this solution. So we remember that zinc fluoride is going to split into 3 ions. We know our boiling point elevation constant is 0.512 degrees Celsius per molality for water. And we now know that the molality of that zinc fluoride solution, that concentration, is 1.47. So we just simply multiply 3 times 0.512 times 1.47, and that gives us 2.25792. Now, again, we have to go back, and there are 3 significant figures here, so we can only have 3 significant figures in our answer. Again, we're going to go to the hundredths position, but we're going to look at the number to the right. That is a 7, which means we round this number 5 up to a 6. So our change in the temperature is 2.26 degrees Celsius. This simply means that the new boiling temperature for this solution of zinc chloride when dissolved in water is going to be 2.26 degrees higher than the original boiling point for water. So the boiling point for water is 100.0 degrees Celsius. In order to find the new boiling point for this zinc chloride solution, we have to add 100.0 degrees Celsius plus 2.26 degrees Celsius. And that will give us an answer of 102.26 degrees Celsius. Now, you have to remember, go all the way back to Module 1, Module 2, and remember that when you add numbers, the significant figures rule is that you have to have the least precise number of significant figures. So in this number, it goes to the 10th position. This number goes to the hundredths position. Our final answer can only go out as far as the 10th position, which means it can only go out to the 10th position, but we have to look at this number to tell me whether or not this 2 will remain a 2, or if this number is 5 or above, we're going to round up. Since it's 6, we round that up. Our final answer is our new boiling point for the 1.47 molar solution of sodium chloride is 102.3 degrees Celsius. It's a lot to remember because it's taken me 2 pages to get down to this answer, and you have to remember what your original question was asking for. It wanted the new boiling point. It didn't ask for the change in the boiling temperature, but it wanted what was the new boiling point. So there is a lot to remember when doing these problems.